All right, let's jump into a question that sounds like it's straight out of science fiction, but when you really dig into it, it reveals these incredible invisible forces that make our entire world possible. What if the very ground beneath our feet just stopped spinning?
So, to even begin to answer that, you need to know this number 1,670 kilometers per hour. That is how fast the Earth is rotating at the equator. And just to put that in perspective, that is faster than the speed of sound.
And here is the craziest part. You are moving that fast right now. Me, you, the oceans, the air, everything is a passenger on this supersonic journey through space. And the only reason we don't feel it is because the motion is so incredibly smooth and constant. It's a stability we take completely for granted. So, let's run the thought experiment. What if that constant, reliable motion, the very thing that gives us our day and night, suddenly just wasn't there anymore?
Before we can talk about stopping it, we have to appreciate what it actually is. This spin, it's not some random thing. It's basically the leftover momentum from the birth of our solar system 4.5 billion years ago. It's this ancient, constant force that gave us the 24-hour cycle that really all life on Earth has evolved around.
To really get our heads around the consequences, we have to look at two totally different ways this could go down. First, there's the instant catastrophic stop, a brutal lesson in pure physics. And then there's the slow, gradual stop, a bizarre transformation into an utterly alien world. Let's start with the violent one.
Okay, so in this scenario, imagine the solid planet just instantly breaks. But everything that's not physically bolted to the bedrock, like the atmosphere, the oceans, you and me, well, we'd keep going. This is a terrifying demonstration of Newton's first law of motion, the law of inertia.
Honestly, the best way to think about it is this. The planet is a car traveling at over 1,000 miles an hour, and it just slammed into a cosmic brick wall. The atmosphere and the oceans, they're the passengers who weren't wearing seatbelts, and they go flying right through the windshield. The results are just unimaginable.
And what's really wild is that your fate in this chaos depends entirely on where you are. If you're at the equator, you're hit by a sustained Mach 1.3 blast wave that would literally scour the surface down to bedrock. But if you were standing right at the North or South Pole, the very axis of the spin, you wouldn't be thrown sideways. You just feel the most violent earthquake in history. For a second, you might even think you survived.
And let's be absolutely clear. You can't even call this wind. This is a kinetic energy event. It's a sustained shock wave. The friction from this supersonic air moving over the now stationary ground would create so much heat, it would basically incinerate anything that wasn't already smashed to bits.
And right behind that wall of air, the oceans arrive. The entire body of water on the planet keeps moving at over 1,000 miles an hour, slamming into the eastern edges of every continent. This isn't a wave, it's the entire ocean itself, acting as one giant battering ram, washing over entire mountain ranges. Places like Florida, all of the UK, Japan, they would just be gone instantly. And deep beneath the surface, the planet itself would be tearing apart. The unbelievable shear forces would trigger every single fault line at once. We're talking about earthquakes that are literally off the scale, triggering massive volcanic eruptions across the globe. It's a complete, top-to-bottom planetary failure.
Okay, let's just take a deep breath.
That was the violent end. But what if the Earth just gradually slowed down over thousands of years? Well, in this case, inertia isn't the killer. Instead, it's a slow, kind of fascinating rebalancing of the planet's most fundamental forces.
So, the first thing to get is that our planet isn't actually a perfect sphere. Its spin creates a bulge around the equator. Think about spinning pizza dough, right? It flattens out and gets wider in the middle. That's Earth. And that bulge is what holds the oceans in place. As the spin slows, that centrifugal force disappears, and gravity becomes the only game in town. The result? A complete redrawing of the world map. All that water at the equator starts flowing downhill toward the poles. You'd end up with a giant supercontinent wrapping all the way around the Earth's middle, and two enormous isolated oceans at the top and bottom, swallowing up places like Canada, Siberia, and all of Northern Europe. So, with no daily spin, our idea of a day completely changes. Now, it's defined by our orbit around the sun. What you get is a single day that lasts an entire year. 6 months of nonstop, scorching sunlight, followed by 6 months of frozen, absolute darkness. It's like a rotisserie chicken. If you stop turning it, one side just burns to a crisp, while the other stays completely raw. And the temperatures we're talking about are just brutal. The side facing the sun would bake at temperatures hot enough to boil water, while the dark side would plunge into a deep freeze colder than anything in Antarctica. The mild, temperate world we know and love would be gone, replaced by a planet of truly unbearable extremes. But there's one final, really sneaky consequence that happens in both scenarios. It's something that would doom any potential survivors in the long run: the total failure of our planet's magnetic field, our planetary defense system. See, our shield is generated by something called the geodynamo. To put it simply, the Earth's spin constantly churns and swirls the molten iron in its core. All that motion of liquid metal generates a powerful magnetic field that wraps all the way around our planet, and it's what protects us from all the nasty radiation coming from the sun.
It's really a simple recipe. You need three ingredients: a conducting fluid, which is our molten iron core, you need heat to make it move around, and you need rotation to give it that crucial swirl. If you take away the rotation, the whole dynamo just fails. The shield goes down.
And without that shield, well, we'd eventually become a lot like Mars. The sun's solar wind would just slam directly into our atmosphere, slowly but surely stripping it away into space over millions of years. The surface would get bombarded with deadly cosmic radiation, making any kind of complex life totally impossible. So whether it's through that instant, violent end of inertia, or the slow, grinding transformation into an alien world, the lesson is pretty much the same. The rotation of our planet isn't just some simple clock for our days. It's so much more than that. It really is the very pulse of a living planet. It's a constant, silent beat that dictates our climate, our geography, and our very safety from the dangers of space. It's the rhythm that allows the whole symphony of life to even happen. And that kind of leaves you with a final thought, right? This whole exercise just shows how changing one single fundamental thing can unravel everything else. It really makes you wonder, what other invisible forces, what other perfect, delicate balances are at work all around us, right now, making our world possible without us even noticing?